Long before humans walked this planet, before cities rose and fell, before the first breath of civilization, Earth belonged to monsters. Creatures so massive they shook the ground beneath their feet. Predators so lethal they redefined what it meant to survive. For 165 million years, dinosaurs ruled a world we can barely comprehend. Then, in a single catastrophic day, nearly all of them vanished. This is their complete story, from the first stirrings of life in the Triassic to the asteroid that ended an empire. Picture Earth 252 million years ago. You wouldn't recognize it. The continents are fused into one massive supercontinent called Pangaea. The climate is brutal, swinging between scorching deserts and violent monsoons. This is the aftermath of the Permian extinction, the worst mass die-off in planetary history. 96% of all marine species just got erased. 70% of land vertebrates, gone. The planet is essentially starting over. But life doesn't quit that easily. In the wreckage of this devastated world, something new begins to emerge. Small reptiles, no bigger than house cats, start adapting to fill empty ecological niches. These are the archosaurs, the ruling reptiles. They're splitting into two distinct lineages. One branch will eventually become crocodiles, the other, dinosaurs. The first true dinosaurs appear around 230 million years ago during the Triassic period. They're not impressive yet. Species like Eoraptor and Herrerasaurus are relatively small, maybe 3 to 6 feet long. They walk on 2 legs, they're quick, and they're hungry. But they're competing in a world already packed with other reptiles. Massive crocodile relatives called Rauisuchians dominate as apex predators. Flying pterosaurs own the skies. Early dinosaurs are just another group trying to survive. What gives them the edge? Their legs. Unlike other reptiles whose limbs sprawl out to the sides, dinosaur legs are positioned directly underneath their bodies. This might sound trivial, but it's revolutionary. It makes them more efficient movers, better runners, more agile hunters. Energy that other animals waste just holding themselves up. Dinosaurs channel into speed and endurance. Then something happens that changes everything. About 201 million years ago, massive volcanic eruptions tear through Pangaea. The Central Atlantic magmatic province erupts for hundreds of thousands of years, pumping carbon dioxide and sulfur into the atmosphere. Global temperatures spike, then plummet. Ocean chemistry goes haywire. This is the Triassic-Jurassic extinction event. Roughly 76% of all species die out, including most of those dominant crocodile relatives and many other reptilian competitors. Dinosaurs survive, and suddenly they've got room to grow. The Jurassic period begins 201 million years ago, and this is when dinosaurs truly take over. Pangaea starts breaking apart. The climate becomes warmer and more humid. Forests spread across the continents. Sea levels rise. It's a lush green world, and dinosaurs explode into it. This is when we see the rise of the sauropods, the long-necked giants that define our image of dinosaurs. Species like Brachiosaurus, Diplodocus, and Apatosaurus evolve into the largest land animals that have ever existed. We're talking creatures weighing up to 80 tons, as long as 3 school buses. Their necks stretch 30 feet into the air, letting them browse vegetation other animals can't reach. They're living, breathing skyscrapers. How do bodies that massive even function? The secret is in their bones. Sauropod skeletons are filled with air sacs connected to their respiratory system. These hollow spaces reduce weight without sacrificing strength. It's the same principle that lets birds fly, scaled up to an almost absurd degree. Their digestive systems are equally specialized. They swallow stones, gastroliths, which sit in their stomachs and grind up plant matter like a living mill. But size alone doesn't rule an ecosystem. You need predators to balance it out. Enter the theropods. This is the dinosaur group that includes all the carnivores, the hunters, the killers. Allosaurus emerges as one of the Jurassic's apex predators. reaching lengths of 30 feet and weighing over 2 tons. It hunts in packs, taking down prey much larger than itself. Fossil evidence shows Allosaurus bite marks on sauropod bones. These weren't scavengers picking at carcasses. They were actively hunting giants. Meanwhile, the skies fill with pterosaurs, some with wingspans exceeding 30 feet. The oceans teem with marine reptiles, plesiosaurs and ichthyosaurs that look like something from another planet. Dinosaurs don't just dominate the land. They're reshaping every environment on Earth. The Jurassic also gives us the first appearance of something crucial: birds. Around 150 million years ago, a small feathered dinosaur called Archaeopteryx takes to the air. It's got teeth, claws on its wings, and a long bony tail, but it's undeniably a bird. This isn't some weird evolutionary side project. Birds are dinosaurs. They're part of the theropod lineage. Every pigeon you see today is a direct descendant of these Jurassic pioneers. Then we cross into the Cretaceous period, 145 million years ago. This is the final chapter of the dinosaur era, and it's the longest. It lasts nearly 80 million years. The continents continue drifting apart. South America splits from Africa. India breaks off and starts its journey north. The Atlantic Ocean widens. These geographic changes create isolated ecosystems where dinosaurs evolve in wildly different directions. Flowering plants, angiosperms, appear for the first time. This changes everything. Before this, the world was dominated by ferns, cycads, and conifers. Now you've got flowers, fruits, and a huge boost in plant diversity. Herbivorous dinosaurs adapt to exploit these new food sources. Ceratopsians, the horned dinosaurs like Triceratops, evolve specialized beaks and dental batteries to slice through tough vegetation. Hadrosaurs, the duck-billed dinosaurs, develop hundreds of tightly packed teeth that work like living cheese graters. And then there's Tyrannosaurus rex. It appears around 68 million years ago, near the very end of the Cretaceous. T-Rex is the culmination of millions of years of theropod evolution. 40 feet long, 20 feet tall, weighing up to 9 tons. Its bite force is estimated at over 12,000 pounds, strong enough to crush bone. Those tiny arms everyone jokes about. Irrelevant when you've got jaws that can tear a Triceratops apart. But T-Rex wasn't alone at the top. Depending on where you were on the planet, you might encounter different apex predators. In South America, Giganotosaurus reached similar sizes. In Africa, Carcharodontosaurus ruled. In Asia, Tarbosaurus filled the same ecological role. These weren't just big lizards. They were sophisticated hunters, with forward-facing eyes for depth perception, powerful legs for pursuit, and intelligence comparable to modern crocodiles. The Cretaceous is also when armored dinosaurs reach their peak. Ankylosaurus develops a body covered in bony plates and a tail club capable of shattering bone. Stegosaurus, though technically a Jurassic holdover in some regions, shows us how dinosaurs weaponize their bodies. These aren't passive victims, they're armed and dangerous. Beneath all this, the planet is changing in ways dinosaurs can't see coming. Volcanic activity increases. The Deccan Traps in what's now India begin erupting around 66 million years ago, releasing massive amounts of lava and gas over hundreds of thousands of years. Climate becomes less stable. Sea levels fluctuate wildly. Dinosaur diversity, some evidence suggests, might already be declining slightly before the final blow arrives. Then, on an ordinary day, 66 million years ago, the sky catches fire. An asteroid 6 miles wide, traveling at over 40,000 miles per hour, slams into what's now the Yucatan Peninsula in Mexico. The impact releases energy equivalent to 10 billion Hiroshima bombs. The explosion vaporizes rock, creates earthquakes measuring magnitude 11, and triggers tsunamis hundreds of feet tall. But that's just the beginning of the end. The asteroid impact creates a crater 110 miles wide and 12 miles deep. Rock liquefies instantly. A fireball expands outward, incinerating everything within 1,000 miles. Molten debris shoots back into space, then rains down across the entire planet as burning meteors. Forests ignite globally. The air itself becomes an oven. Within hours, massive tsunamis circle the globe. Coastal regions are scoured clean. Inland seas slosh violently, drowning ecosystems that had thrived for millions of years. Earthquakes ripple outward from the impact site, triggering landslides and volcanic eruptions worldwide. But the real killer isn't the initial blast. It's what comes after. Trillions of tons of pulverized rock and sulfur compounds are ejected into the atmosphere. The sky goes black. Photosynthesis stops. Temperatures plummet. This isn't a quick freeze either. The darkness lasts months, possibly years. Plants die. Herbivores starve. Then the carnivores that depended on them collapse. The food chain disintegrates from the bottom up. Acid rain follows. Sulfur dioxide mixes with water vapor, creating sulfuric acid that pours from the sky. Oceans acidify. Marine ecosystems, already stressed by the Deccan Trap's volcanism, suffer catastrophic losses. Ammonites, marine reptiles, and countless species of plankton vanish forever. Approximately 75% of all species on Earth go extinct. Every non-avian dinosaur dies. Triceratops, Tyrannosaurus, Ankylosaurus, the hadrosaurs, the sauropods that still roamed southern continents. Gone. The reign that lasted 165 million years ends in a geological instant. But here's what most people miss. The extinction wasn't random. Small animals survived. Mammals, most of which were no bigger than rats at this point, make it through. They can burrow underground, hide from temperature extremes, and survive on insects and dead organic matter. Birds, the flying descendants of theropods, survive because many species can migrate, adapt quickly, and exploit diverse food sources. Crocodilians survive because they're cold-blooded ambush predators that can go months without eating. Turtles, with their slow metabolisms and ability to hunker down in water or mud, endure. Large animals die. If you weighed more than about 55 pounds, your chances of survival dropped dramatically. Size, which had been an advantage for dinosaurs throughout the Mesozoic, becomes a fatal liability. You need too much food. You can't hide. You can't wait it out. The world that emerges from this catastrophe is unrecognizable. The Cenozoic era begins. This is our era, the age of mammals. At first, the planet is a graveyard. Ferns, which reproduce via spores and can lie dormant through harsh conditions, are among the first plants to return. Fossil records show a fern spike immediately after the extinction, a layer of rock dominated by fern spores. It's the Earth trying to reboot. Mammals, freed from 165 million years of living in dinosaurs' shadows, explode in diversity. Within 10 million years, you've got mammals filling ecological niches dinosaurs once occupied. Herbivores grow larger to process vast amounts of plant matter. Carnivores evolve to hunt them. Some mammals even return to the oceans, beginning the lineage that leads to whales. Birds diversify rapidly, without pterosaurs competing for airspace and large theropods dominating the ground. Birds radiate into thousands of species. Some stay small. Others, like the terror birds of South America, grow to 10 feet tall and become apex predators. These flightless carnivores have massive beaks capable of crushing skulls. They're essentially dinosaurs reclaiming their throne, but they won't last. Mammalian predators eventually outcompete them. So where does this leave us? What's the future of dinosaurs? Well, birds are dinosaurs. That's not metaphorical. Phylogenetically, taxonomically, birds are avian dinosaurs. There are roughly 10,000 species of birds alive today. That's more species than all mammals combined. Dinosaurs didn't go extinct. They adapted, survived, and thrived. But what about non-avian dinosaurs? Could they return? The Jurassic Park fantasy, cloning dinosaurs from ancient DNA, faces insurmountable problems. DNA degrades, even under perfect conditions, frozen in amber or preserved in bone. DNA has a half-life of about 521 years. After 6.8 million years, every bond would be broken. Dinosaur DNA is 66 million years gone. We'll never recover a usable genome. However, there's another approach: reverse engineering. Birds carry dinosaur genes. They're modified, suppressed, but still there. Chickens, for instance, have genes for teeth. Dinosaurs had teeth. Birds lost them. But if you activate those dormant genes, chicken embryos start developing teeth. Scientists have done this. They've also triggered tail growth in bird embryos, creating structures more similar to dinosaur tails than modern bird tails. This isn't Jurassic Park. You're not getting a velociraptor. But you could, theoretically, create a creature more dinosaur-like than any living bird. A chickenosaurus with teeth, a long tail, and modified forelimbs. It's genetic tinkering, not resurrection, but it demonstrates that dinosaur traits haven't been erased. They're just switched off. There's also the question of whether dinosaurs, or something like them, could evolve again. Evolution doesn't repeat exactly, but it finds similar solutions to similar problems. This is called convergent evolution. Sharks, ichthyosaurs, and dolphins all evolved similar body shapes for swimming, despite being fish, reptiles, and mammals respectively. If conditions favored large terrestrial herbivores and carnivores again, could something dinosaur-like emerge? Possibly, but it would take millions of years and a very different world. Right now, mammals dominate. Ecosystems are structured around mammalian metabolism, reproduction, and behavior. For reptilian giants to rise again, you'd need a mass extinction that clears out mammals, a climate shift that favors cold-blooded physiology, and evolutionary pressures that reward size. None of that seems imminent. Mammals are too entrenched. But let's imagine a different scenario. What if humans disappeared tomorrow? What would happen to birds? Birds are already incredibly diverse and adaptable. Remove human pressure, urban sprawl, agriculture, and pollution, and birds would likely continue diversifying. Some might grow larger, filling niches left by extinct mammals. Flightless birds could become more common in predator-free environments. Raptors might evolve into larger, more dominant hunters. Over tens of millions of years, you could see avian dinosaurs reclaiming ecological roles their ancestors lost. It's also worth considering that dinosaurs, as a group, were stunningly successful. They dominated terrestrial ecosystems for 165 million years. Humans, by comparison, have been around for about 300,000 years. Modern civilization is maybe 10,000 years old. Dinosaurs outlasted countless climate shifts, continental rearrangements, and evolutionary competitors. Their extinction wasn't a failure. It was bad luck, a rock from space, and even then, they didn't entirely disappear. Every sparrow, every eagle, every penguin is proof that dinosaurs adapted and survived the worst catastrophe in 66 million years. So what's the legacy of dinosaurs? They teach us that dominance is temporary, that evolution favors adaptability over size, that life, despite unimaginable catastrophe, finds a way to persist. Dinosaurs also reveal something humbling. We live in their world. The oxygen we breathe, the ecosystems we depend on, the evolutionary pressures that shaped mammals, all of it was influenced by dinosaurs. They built the Mesozoic world, and their extinction created the space for our lineage to emerge. If that asteroid had missed, would mammals ever have risen? Would primates exist? Would humans? Probably not. We owe our existence to a cosmic accident that ended theirs. The story of dinosaurs isn't just about the past. It's about understanding how life responds to change, how ecosystems collapse and rebuild, and how nothing, no matter how dominant, is permanent. Right now, we're living through another mass extinction. Species are disappearing at rates not seen since the asteroid impact. Ecosystems are collapsing under human pressure. Dinosaurs survived for 165 million years. We've barely started. Whether we make it as long depends on choices we make now. The question isn't whether life will survive. It will. Life survived the asteroid. Life survived the worst Earth could throw at it. The question is whether we will, and what we'll leave behind when we're gone. Life doesn't ask permission to start over. After the asteroid, Earth was a furnace, then a freezer, then silent. But silence doesn't last. Within 1,000 years, ferns blanketed the scorched ground. Within 10,000, forests returned. Within 100,000, new creatures walked where tyrannosaurs once ruled. The planet didn't mourn dinosaurs. It simply moved on. This is the part of the story we rarely tell. Not the extinction, but what happened after. Because the real question isn't why dinosaurs disappeared. It's what replaced them, and why that matters for understanding where life goes next. Immediately after the impact, Earth's ecosystems were obliterated. The food chain collapsed from the top down and bottom up simultaneously. Plants died first, starved of sunlight. Herbivores followed, then carnivores. Small creatures that could hide, scavenge, or hibernate had the advantage. Mammals, already present but marginal, suddenly found themselves in a world without competition. No massive predators. No giant herbivores stripping forests bare. Just opportunity. Mammals had been around for over 160 million years during the Mesozoic, but they stayed small. Most were nocturnal, shrew-sized, eating insects and staying out of sight. Dinosaurs owned the day. But when dinosaurs vanished, mammals exploded in diversity. Within 10 million years, species ranged from tiny shrews to dog-sized herbivores. Within 20 million years, some were as large as bears. Evolution works fast when niches open up. But mammals weren't the only survivors. Crocodilians made it through. So did turtles, lizards, snakes, and amphibians. Fish diversified rapidly in recovering oceans. Birds, the only surviving dinosaur lineage, spread across every continent. For a brief period, giant flightless birds became apex predators. In South America, terror birds stood 10 feet tall with massive beaks capable of crushing bone. They dominated for millions of years until mammalian predators evolved to challenge them. This is convergent evolution in action. Remove dinosaurs and something else fills the role. Terror birds were essentially reptilian predators in avian form. Mammalian carnivores evolved similar hunting strategies. Both groups developed size, speed, and power because those traits work. Evolution doesn't care about the package, it cares about function. Meanwhile, Earth's climate was shifting. The asteroid triggered rapid cooling, but over millions of years, temperatures stabilized and began warming. The Paleocene and Eocene epochs were hot, humid, and lush. Forests covered much of the planet. In this greenhouse world, mammals thrived. Primates appeared. Early whales transitioned from land to sea. Grass, a relatively new plant type, began spreading across continents, creating vast savannas. Grasslands changed everything. Grass is tough, fibrous, hard to digest. Mammals that could process it gained access to endless food. Herbivores evolved specialized teeth and multi-chambered stomachs. Horses, once small forest dwellers, grew larger and faster on open plains. Predators followed. Saber-toothed cats, dire wolves, and hyenas diversified. Ecosystems became complex again, structured around different rules, but functionally similar to what came before. Here's the paradox. Life after dinosaurs wasn't radically different. It was structurally similar. Large herbivores eating plants, large carnivores hunting them, scavengers cleaning up, insects pollinating, decomposers recycling nutrients. The roles remained, only the actors changed. This suggests something fundamental about ecosystems. Certain structures work, certain relationships are stable. Evolution rediscovers them repeatedly. Now, fast forward to the Pleistocene, roughly 2.6 million years ago. Earth entered an ice age cycle. Glaciers advanced and retreated over tens of thousands of years. Megafauna emerged. Woolly mammoths, giant ground sloths, saber-toothed cats, massive bears. These creatures were Earth's new giants, filling ecological roles once held by sauropods and theropods. But unlike dinosaurs, megafauna faced a new threat: humans. Homo sapiens appeared around 300,000 years ago. For most of that time, we were just another predator, smart, adaptable, but not dominant. Then something changed. We developed language, complex tools, social structures. We learned to hunt cooperatively, use fire, and alter landscapes. Everywhere humans spread, megafauna disappeared. Mammoths, giant sloths, marsupial lions, gone. Some scientists debate whether climate or hunting caused these extinctions. Most evidence points to both, with humans as the tipping point. This brings us to now. Humans dominate Earth more completely than any species in history. We've reshaped continents, altered the atmosphere, and driven extinction rates to levels not seen since the asteroid. We're functionally a geological force. The Anthropocene, some call it. The age of humans. But dominance doesn't equal permanence. Dinosaurs were dominant for 165 million years. We've barely started. What happens next depends on us. Climate change is accelerating. Ecosystems are collapsing. Species are vanishing. We're conducting an uncontrolled experiment on planetary systems, and the results are unpredictable. Some scientists warn we're triggering Earth's 6th mass extinction. Others argue we can still reverse course. Either way, the planet will survive. It always does. The question is what form life takes afterward. If humans disappeared tomorrow, what would Earth look like in 1,000,000 years? 10 million? 100 million? Nature would reclaim everything we built. Cities would crumble. Roads would vanish under vegetation. Within centuries, forests would cover former farmland. Within millennia, most traces of civilization would erode away. Animals would repopulate. Evolution would continue. Some species would thrive. Rats, pigeons, cockroaches, creatures adapted to human environments, might struggle initially, but would adapt. Others, freed from human pressure, would explode in diversity. Predators would rebalance ecosystems. Herbivores would spread. Over millions of years, entirely new species would emerge. Perhaps something intelligent, perhaps not. Intelligence isn't inevitable. It's one evolutionary strategy among many. Could something like dinosaurs return? Technically, yes. Evolution can produce similar forms under similar pressures, but it wouldn't be dinosaurs. It would be something new that happened to look dinosaur-like. More likely, mammals would continue diversifying. Birds might grow larger, filling niches left empty. Reptiles could expand into new roles. Life doesn't repeat, it improvises. The deeper lesson from dinosaur extinction is this: nothing lasts forever, but life itself endures. Individuals die, species go extinct, ecosystems collapse. But life as a phenomenon persists. It adapts, evolves, rebuilds. The asteroid that killed dinosaurs didn't end life. It redirected it. Whatever comes next, whether humanity survives or vanishes, life will continue. Different forms, different strategies, same fundamental drive. Dinosaurs teach us humility. They dominated longer than we've existed. They survived climate shifts, volcanic eruptions, continental drift. They were successful by any measure, and they still ended, not because they failed, but because circumstances changed beyond their control. We face similar uncertainty. Our success isn't guaranteed. Our dominance is temporary. What we do with the time we have determines what comes after. Right now, we're at a crossroads. We can continue exploiting ecosystems until they collapse, triggering cascading extinctions and destabilizing the planet. Or we can adapt, reduce our impact, and coexist with other species. Dinosaurs didn't have a choice. We do. That's both a privilege and a responsibility. The history of dinosaurs isn't just ancient history, it's a preview. A reminder that Earth operates on timescales beyond human comprehension, that life's resilience exceeds any single species' dominance, and that extinction is always one catastrophe away. We live in their shadow, in a world they built and lost. Understanding them means understanding our place in the same relentless cycle. What if the asteroid never hit? What would Earth look like today if dinosaurs never went extinct? That question haunts paleontologists because the answer reveals just how accidental our existence truly is. Remove one rock from space 66 million years ago, and mammals likely never dominate. Primates never evolve. Humans never exist. The world belongs to something else entirely. Let's explore that alternate timeline, then return to what actually happened and why it matters. Without the asteroid, dinosaurs would have continued evolving. They weren't static creatures frozen in time. They were actively adapting, diversifying, filling every available niche. Tyrannosaurs were getting larger. Raptors were developing more sophisticated hunting strategies. Herbivores were evolving better defenses. In this alternate Earth, 66 million years of additional evolution would have produced forms we can barely imagine. Some paleontologists speculate certain dinosaurs might have developed human-level intelligence. Troodon, a small theropod with a relatively large brain-to-body ratio, showed promise. Given enough time, could it have evolved sapience, tool use, language? It's speculative, but not impossible. Intelligence evolved in primates, corvids, cetaceans, octopuses. Different lineages, similar outcomes. Intelligence is a useful adaptation under the right pressures. But here's the catch. Intelligence isn't inevitable. It's expensive, metabolically demanding, and only advantageous in specific environments. Troodon might have remained clever but non-sapient, or gone extinct, or evolved into something unrecognizable. Evolution doesn't aim for intelligence, it stumbles into it occasionally. More likely, dinosaurs would have simply continued radiating into new forms. Imagine sauropods evolving even longer necks to reach taller trees as forests grew denser. Picture marine reptiles, which weren't technically dinosaurs, but coexisted with them, developing echolocation like whales. Envision flying pterosaurs growing larger or smaller, depending on available prey. The Cretaceous was already incredibly diverse. Another 66 million years would have compounded that diversity exponentially. Mammals, meanwhile, would have remained small. They'd existed alongside dinosaurs for over 150 million years, never breaking free from nocturnal, rat-sized niches. Dinosaurs dominated daytime ecosystems. Mammals survived by avoiding them. Without the extinction event, that dynamic continues indefinitely. Mammals stay small, hidden, marginal. No primates, no apes, no humans. Our lineage never escapes the underbrush, but the asteroid did hit, and everything changed in an instant. Let's walk through those final moments in detail, because understanding the mechanics of extinction reveals how fragile dominance really is. The asteroid struck the Yucatan Peninsula with the force of 10 billion Hiroshima bombs. The impact vaporized rock, creating a fireball that radiated outward at thousands of degrees. Everything within 1,000 miles died instantly. The shockwave flattened forests across continents. Tsunamis hundreds of feet tall ravaged coastlines. But those immediate effects, devastating as they were, weren't the primary killers. The real damage came from what the impact threw into the atmosphere. Trillions of tons of debris launched skyward. Dust, ash, vaporized rock. It spread globally within hours, blocking sunlight. Temperatures plummeted. Photosynthesis stopped. Plants died. Herbivores starved. Carnivores followed. The food chain collapsed from the bottom up. This is called an impact winter, and it lasted years, possibly decades. Darkness, cold, silence. Ecosystems that had flourished for millions of years disintegrated. Dinosaurs, particularly large ones, couldn't adapt fast enough. They required enormous amounts of food. When that food disappeared, they starved. Smaller dinosaurs fared slightly better initially, but the cascading collapse eventually reached them too. Birds, the only dinosaur lineage that survived, made it through because of their size, flight ability, and dietary flexibility. They could migrate, scavenge, exploit resources unavailable to ground-bound relatives. Mammals survived for similar reasons. Small body size meant lower caloric needs. Burrowing behavior provided insulation against temperature drops. Omnivorous diets allowed flexibility when preferred foods vanished. They weren't thriving, but they endured. Here's what's critical. Survival wasn't about superiority. It was about luck and circumstance. Dinosaurs weren't inferior to mammals. They were adapted to a world that suddenly stopped existing. When the rules changed overnight, their adaptations became liabilities. Size, once an advantage, became a death sentence. Specialization, previously beneficial, turned fatal. The survivors weren't the strongest or smartest. They were the ones whose traits happened to match the new reality. This is a fundamental lesson of extinction. Dominance means nothing when the environment shifts faster than evolution can respond. The recovery took millions of years. Initially, Earth was a wasteland. Fungi thrived on dead organic matter, blanketing landscapes in decomposition. Early survivors like ferns spread quickly, opportunistic and hardy. Slowly, ecosystems rebuilt, forests regrew, food webs reconnected. Mammals began diversifying into niches previously occupied by dinosaurs. By 10 million years post-impact, mammalian lineages had exploded in variety. By 30 million years, recognizable ancestors of modern groups appeared. Primates emerged. Whales returned to the oceans. Elephants grew enormous. Mammals didn't just fill the gaps dinosaurs left. They reimagined those roles entirely. Where dinosaurs had used size and power, mammals developed speed, intelligence, social structures. Different strategies, same ecosystems. And this brings us to a strange truth. We owe our existence to catastrophe. The asteroid that killed dinosaurs didn't just create space for mammals. It fundamentally reshaped evolutionary possibilities. Without that impact, Earth's trajectory would have been unrecognizable. Dinosaurs might have dominated indefinitely. Mammals might have remained marginal forever. Intelligence might never have evolved in any lineage. Our existence isn't the result of gradual progress. It's the outcome of violent disruption. That should terrify and humble us. We're not the culmination of evolution. We're one branch on a tree that nearly burned down, regrowing from scorched roots. Now consider this. Extinction events aren't rare. Earth has experienced at least 5 major mass extinctions, each reshaping life dramatically. The Permian extinction, 252 million years ago, killed 96% of marine species and 70% of terrestrial vertebrates. Volcanic eruptions, ocean acidification, oxygen depletion. Life nearly ended, but it didn't. It recovered, diversified, and eventually produced dinosaurs. The Ordovician extinction, 445 million years ago, wiped out 85% of species. The Devonian, the Triassic, each event catastrophic, each followed by recovery. Life doesn't just survive extinction, it uses extinction as a reset button, clearing out old forms and enabling new experiments. Extinction is creative destruction. What does this mean for us? We're currently causing what scientists call the Holocene or Anthropocene extinction. Species are disappearing at rates comparable to past mass extinctions, but this time there's no asteroid. The cause is us. Habitat destruction, climate change, pollution, overhunting. We're driving biodiversity loss on a geological scale. Some estimates suggest extinction rates are 100 to 1,000 times higher than background rates. We're functionally an extinction event. But here's the difference. We can stop. Asteroids don't change course. Volcanoes don't negotiate. We can choose differently. The question is whether we will. History suggests dominance doesn't last. Dinosaurs dominated for 165 million years and vanished. Trilobites dominated oceans for 270 million years and went extinct. Humans have existed for maybe 300,000 years. Civilization for 10,000. We're infants by geological standards, yet we're behaving like we're permanent. We're not. Every species eventually goes extinct, either through catastrophe or evolution into something else. Our descendants, if they exist millions of years from now, won't be human as we define it. Evolution doesn't stop. We're transitioning constantly, imperceptibly, toward whatever comes next. So what comes after humans? If we vanish tomorrow, mammals continue. Primates might produce another intelligent species eventually, or maybe corvids, already tool users with complex cognition. Maybe octopuses, if they ever overcome their short lifespans. Or maybe nothing intelligent emerges again. Intelligence isn't destiny. It's one option among infinite possibilities. Earth doesn't need intelligent life. It functioned for billions of years without it. If intelligence disappears, ecosystems adjust and continue. Life doesn't care about consciousness. It cares about survival and reproduction. Anything achieving that succeeds. The story of dinosaurs, from their rise in the Triassic to their extinction in the Cretaceous, is ultimately a story about time, change, and impermanence. They weren't failures. They were extraordinarily successful, enduring longer than most lineages ever will. Their extinction wasn't punishment for inferiority. It was bad luck, cosmic scale randomness. And their legacy isn't absence. It's us, the mammals they inadvertently enabled. It's birds, their direct descendants. It's every ecosystem shaped by their disappearance. Understanding dinosaurs means understanding that success is temporary, that dominance is circumstantial, and that life's story is written by survivors, not victors. What happens next depends on whether we learn that lesson or ignore it. The future isn't written, but patterns suggest where we're headed. Mammals currently dominate terrestrial ecosystems. We've filled niches dinosaurs once occupied, though differently. No mammal matches the largest sauropods in size. Physics and biology impose limits. Elephants represent near maximum land mammal mass. Larger bodies require proportionally stronger bones, more food, different circulatory systems. Sauropods managed it through unique adaptations. Air sacs reducing weight, efficient respiratory systems, possibly different metabolisms. Mammals lack those advantages. We're built differently, constrained differently, but constraints change. Environments shift. What's impossible now becomes possible later. Consider whales. They returned to oceans and became the largest animals ever, surpassing even the biggest dinosaurs. Blue whales reach 200 tons. Water supports weight that land cannot. Different environment, different possibilities. Evolution exploits every available option given enough time. So what could emerge in the next 100 million years? Climate determines much. If Earth warms significantly, tropical zones expand. Deserts might dominate continents. Heat-adapted species thrive while cold-adapted ones retreat or vanish. Reptiles could reclaim prominence. They're ectothermic, requiring less food than endothermic mammals. In resource-scarce hot environments, that's advantageous. We might see giant lizards again, not dinosaurs, but functionally similar. Or if Earth cools, entering another ice age, cold-adapted mammals expand. Perhaps new megafauna evolves, giant versions of current species, or entirely novel forms. Ocean ecosystems face their own trajectories. Coral reefs are dying now due to warming and acidification. If they collapse entirely, ocean biodiversity crashes temporarily before new ecosystems establish. Different organisms become reef builders. Perhaps sponges or algae create new structures. Marine reptiles could re-emerge. Millions of years ago, ichthyosaurs and plesiosaurs dominated oceans. They went extinct, but their niches remain. Dolphins and whales fill some, but not all. Evolution might produce new marine reptiles from modern lizards or snakes, or mammals could diversify further into forms we'd barely recognize. Flight presents interesting possibilities. Birds dominate aerial niches now, but bats prove mammals can fly. Could other lineages evolve flight? Perhaps primates, developing gliding membranes that eventually become powered flight. Or rodents, already diverse and adaptable. Insects will likely continue dominating small-scale flight. They've done so for hundreds of millions of years. But large flyers, that depends on atmospheric composition. Higher oxygen levels enable larger flying animals. Lower oxygen restricts size. Earth's oxygen concentration fluctuates over geological time, driven by plant life and ocean chemistry. Future oxygen levels could permit giant flyers again or restrict flight to smaller forms. Intelligence is unpredictable. We assume intelligence is advantageous, but evolution doesn't agree. It's expensive. Brains consume enormous energy. Human brains use 20% of our calories despite being 2% of body mass. That's costly. Intelligence only persists if benefits outweigh costs. For humans, it enabled tool use, language, cooperation, and technological civilization. Those benefits justified the expense. But if civilization collapses, does intelligence remain advantageous? Maybe. Maybe not. Survival might favor simpler, hardier organisms. Other species show intelligence potential. Corvids solve complex problems, use tools, plan for the future. Octopuses demonstrate remarkable problem-solving despite short lifespans and solitary behavior. Elephants have complex social structures, long memories, possible self-awareness. Dolphins and whales exhibit sophisticated communication and social behaviors. Any of these lineages could, given tens of millions of years and the right pressures, evolve greater intelligence. Or none might. Intelligence isn't inevitable. It's one possible adaptation among countless others. Technology complicates predictions. If humanity survives and continues advancing, we might fundamentally alter Earth's trajectory. Genetic engineering could resurrect extinct species or create entirely new ones. We could terraform environments, engineer ecosystems, even modify ourselves beyond recognition. Transhumanism suggests merging biology with technology, producing entities neither fully biological nor fully artificial. That's speculative, but not impossible. Technology accelerates change in ways evolution cannot match. Alternatively, technology might cause our extinction. Nuclear war, engineered pandemics, runaway artificial intelligence, environmental collapse. Any could end civilization or humanity entirely. If that happens, Earth continues without us. Evolution resumes its slow, indifferent work. The planet has time. 4 billion years remain before the sun expands and renders Earth uninhabitable. That's enough time for life to reinvent itself dozens of times over. Imagine Earth 100 million years from now. Continents have shifted. Mountain ranges have risen and eroded. Coastlines are unrecognizable. Climates have changed multiple times. Species alive today are mostly extinct. New species, descended from survivors, fill every niche. Some might resemble dinosaurs in form or function, products of convergent evolution. Others might be utterly alien, shaped by environments we can't predict. Perhaps intelligence re-emerges, a new species developing language and technology. They discover fossils of humans and wonder about us the way we wonder about dinosaurs. They reconstruct our civilizations from ruins and speculate about our disappearance. Maybe they find our warnings about climate change or nuclear weapons and learn from our mistakes. Or maybe they repeat them. Or perhaps intelligence never re-emerges. Earth becomes a planet of complex ecosystems without self-awareness. Life flourishes, evolves, diversifies, but no species asks why. That's equally valid. Intelligence isn't life's goal. Life has no goal. It simply continues, adapting to whatever circumstances arise. The story of dinosaurs teaches us that dominance is temporary. They ruled Earth for 165 million years, far longer than mammals have existed. yet they vanished. Not through weakness, but through randomness. An asteroid didn't target them specifically. It simply hit, and they happened to be there. Survival is often luck. The mammals that survived weren't superior. They were smaller, required less food, adapted faster to rapid environmental changes. Right traits, right time. Humans currently dominate Earth through technology and numbers. We've altered ecosystems globally, driven countless species to extinction, changed atmospheric composition, and modified landscapes. By any measure, we're a successful species. But success now doesn't guarantee survival later. Dinosaurs were successful until they weren't. Every dominant lineage eventually falls. The question isn't if, but when and how. We have advantages dinosaurs lacked. We understand extinction. We know asteroids exist and could potentially deflect them. We comprehend climate change and could mitigate it. We possess knowledge dinosaurs never could. But knowledge doesn't ensure action. Understanding threats and preventing them are different things. History shows humans often act only when catastrophe is imminent or already occurring. By then, it's often too late. The future remains unwritten, but probabilities exist. Continued environmental degradation likely causes mass extinction, possibly including us. Climate change, habitat destruction, pollution, and biodiversity loss are accelerating. Reversing course requires collective action on scales humanity has never achieved. Possible? Yes. Likely? History suggests otherwise. If we vanish, life continues. Evolution fills gaps we leave behind. New species emerge, ecosystems stabilize, and Earth moves forward. The planet doesn't need us. It existed for 4 billion years before us and will exist long after. Our significance is self-assigned. From Earth's perspective, we're one experiment among billions. Dinosaurs weren't failures. They were phenomenally successful, enduring eras we can barely comprehend. Their extinction wasn't deserved. It was arbitrary. And their legacy persists in birds, in mammals, in every ecosystem shaped by their absence. We're products of their extinction. Our existence depended on their disappearance. What legacy will we leave? If intelligence re-emerges millions of years hence, will future beings find our fossils and marvel at our cities? Will they learn from our mistakes or repeat them? Or will intelligence never arise again, and our cities crumble into geological strata, compressed into thin layers of plastic and concrete? Curiosities in the rock record. The lesson isn't that extinction is inevitable, though it is. The lesson is that time is vast, change is constant, and nothing lasts. Dinosaurs thrived for incomprehensible spans and vanished in an instant. We've thrived for a geological blink and assume permanence. That assumption is dangerous. Recognizing our impermanence doesn't mean surrendering. It means understanding stakes. We're temporary custodians of this planet, not its masters. Acting like masters ensures our extinction. Acting like custodians might delay it. The choice for now remains ours. Time will reveal whether we choose wisely. The question isn't whether we'll survive. It's whether survival even matters in the context we're discussing. Dinosaurs survived 165 million years, and we call their end tragic. But tragedy implies loss of potential. They fulfilled their potential. They dominated longer than any terrestrial lineage, before or since. Measuring success by duration, they won. Measuring by adaptation, they won. Measuring by diversity, they won. Their only failure was being unable to survive an asteroid, which isn't failure at all. It's physics. We've existed 300,000 years. Civilization maybe 10,000. We're statistically insignificant, yet act like we've conquered time itself. We haven't. We're borrowing it. Every species borrows time from the universe and eventually returns it. The loan comes due through extinction, evolution into something unrecognizable, or both simultaneously. We're not exempt. No intelligence level grants immunity from this reality. Consider the absurdity of our situation. We're the first species in Earth's history capable of understanding our own extinction risk. We can model climate systems, track asteroid trajectories, analyze biodiversity loss. We possess tools to potentially prevent our demise, yet we're accelerating toward multiple extinction scenarios simultaneously. Climate change, habitat destruction, nuclear proliferation, engineered pandemics. We've identified the threats, calculated the timelines, and largely chosen inaction. Future species, if they achieve intelligence, will study this period with fascination. A species smart enough to understand its doom, but not wise enough to prevent it. Dinosaurs get no such criticism. They couldn't have stopped the asteroid. They lacked technology, abstract thought, predictive modeling. Their extinction was purely circumstantial. Ours, if it comes through preventable causes, would be willful. That's the distinction. They died through cosmic randomness. We might die through cosmic irony, killed by the intelligence that was supposed to ensure survival. But maybe extinction isn't the endpoint we imagine. Every mass extinction in Earth's history led to explosive diversification afterward. The Permian extinction killed 96% of species and gave rise to dinosaurs. The Cretaceous extinction killed dinosaurs and gave rise to mammals. The pattern holds across geological time. Extinction clears ecological space. Evolution fills it. Life doesn't mourn the dead. It exploits the vacancy. If humans vanish tomorrow, something else rises. Maybe it's another intelligent species. Maybe it's ecosystems so complex and interconnected that consciousness becomes distributed rather than centralized. Maybe intelligence itself was an evolutionary dead end, a strategy that worked briefly, but ultimately consumed more resources than it provided. We assume intelligence is the peak of evolution because we're intelligent. That's bias, not evidence. Evolution has no peak. It has infinite variations, testing strategies endlessly. Intelligence is one strategy. Camouflage is another. Venom, speed, size, reproduction rate. Each works under certain conditions. None works universally. Birds are living dinosaurs. That's not metaphor or approximation. Phylogenetically, taxonomically, functionally, birds are avian dinosaurs. When we say dinosaurs went extinct, we're wrong. Non-avian dinosaurs went extinct. The lineage survived, adapted, and currently thrives with 10,000 species worldwide. They lost size and dominance but gained flight and diversity. That's not extinction. That's transformation. Perhaps that's our future too. Not extinction, but transformation. Humanity, as we define it, might end, but whatever comes next could be our descendants. Genetically modified, technologically augmented, evolutionarily altered. The line between human and post-human blurs over millennia. We're changing ourselves faster through technology than evolution could naturally. In 1,000 years, humans might be unrecognizable. In 1,000,000, we might be something we'd currently classify as a different species. That's not death. That's continuation through metamorphosis. Or maybe we genuinely go extinct. No descendants, no transformation, just termination. That's equally valid. Most species that ever existed are extinct. Estimates suggest 99.9% of all species that have lived are gone. Extinction is the default outcome. Survival is the anomaly. We're anomalous now, but reversion to the mean is inevitable. The universe doesn't owe us persistence. It doesn't owe anyone anything. The real question is what happens to knowledge if we vanish? Information doesn't survive extinction well. Dinosaurs left bones, footprints, and fossilized eggs. We'll leave plastic, concrete, and radioactive isotopes. Future geologists will find a thin layer in the rock record marking the Anthropocene. Strange materials, mass extinction signatures, chemical anomalies. They'll know something happened. They won't know what we knew. Libraries decay. Hard drives fail. Digital information requires continuous maintenance. Without us, It disappears within centuries. Stone monuments erode, metal corrodes. Even the pyramids will eventually vanish. Given enough time, Earth erases all evidence. In 100 million years, future species might find no trace we ever existed beyond geological anomalies. All our knowledge, art, history, science, gone. That's the real extinction, not of bodies, but of accumulated understanding. Unless we encode knowledge into something permanent, engrave information onto materials that survive geological timescales. Gold doesn't corrode. Ceramics last millions of years. We could theoretically create archives designed to outlast our species, messages to whoever comes next. Some scientists have proposed exactly this, not for aliens, but for future Earth intelligences. A library built to survive planetary catastrophe, containing fundamental knowledge about physics, chemistry, biology, warnings about mistakes we made, a gift from the dead to the living. But even that assumes future intelligence. If intelligence never re-emerges, the library sits unread forever. Information without interpretation is noise. A book is just paper and ink unless someone can read it. Our legacy might be archaeological, not intellectual. Future species might dig up our cities the way we excavate dinosaur bones, reconstructing our appearance and behavior from fragments, never understanding what we thought or felt or feared. The story of dinosaurs is the story of time erasing everything. They dominated longer than we can comprehend and left almost nothing. We have fragments, bones turned to stone, footprints frozen in ancient mud, rare fossilized soft tissue. From these fragments, we reconstruct entire ecosystems, behavioral patterns, evolutionary relationships. We're extrapolating billions of years of history from incomplete evidence. Future scientists, if they exist, will do the same with us. They'll find ruins and speculate. They'll discover plastics in rock layers and wonder why. They'll uncover human skeletons and debate our intelligence level. Everything we think is permanent is temporary. Everything we consider significant is contextual. Dinosaurs teach humility, not through their extinction, but through their duration. They survived longer than we likely will. They adapted to climate changes we'd consider apocalyptic. They endured volcanic eruptions that would end our civilization. They persisted through continental drift, sea level changes, atmospheric composition shifts. They were resilient beyond our comprehension. And still, they ended. If something that successful, that adaptable, that enduring can vanish, what chance do we have? The same chance they had. Survive until you don't. Adapt until you can't. Persist until circumstance overwhelms you. There's no shame in that. It's the fundamental condition of existence. Every living thing fights entropy and eventually loses. The fight isn't futile because the outcome is predetermined. The fight is the point. Life exists in opposition to thermodynamic equilibrium, where temporary decreases in entropy, complexity arising from chaos, order emerging from randomness. That we exist at all is improbable. That we persist is miraculous. That we'll end is inevitable. So what do we do with this knowledge? Despair? Nihilism? No, the opposite. If existence is temporary, it's also precious. Every moment is borrowed time. Every experience is irreplaceable. Every species, including ours, is a unique experiment that will never repeat exactly. When we go extinct, the universe loses something genuinely novel. Human consciousness, human creativity, human capacity for abstract thought. These end with us. They might re-emerge in different forms through different lineages, but they won't be human. That particular expression of intelligence vanishes forever. That makes preservation worthwhile. Not because we're cosmically important, we're not, but because we're unique. Every species is. When dinosaurs went extinct, the universe lost their particular way of existing. When we go extinct, it loses ours. Preventing that loss isn't about human exceptionalism. It's about preserving diversity. The universe is richer with more types of existence, more perspectives, more solutions to the problem of survival. Extinction reduces that diversity. Preservation maintains it. We're the first species capable of deliberately preventing our own extinction. That's power and responsibility combined. Dinosaurs couldn't deflect asteroids. We potentially can. Dinosaurs couldn't modify their environment to suit their needs. We do constantly. Dinosaurs couldn't pass accumulated knowledge across generations through anything beyond genetics. We can. These advantages might save us, or they might doom us. Technology is neutral. It amplifies human tendencies, good and bad. If we're wise, technology extends our survival. If we're foolish, it accelerates our extinction. The choice isn't between surviving forever or dying immediately. It's between surviving longer or dying sooner. Forever isn't an option. Heat death of the universe ensures that. In trillions of years, entropy wins absolutely. But between now and then, there's time. Vast, incomprehensible amounts of time. We could survive millions of years. We could evolve into forms that survive billions. We could spread to other planets, other star systems, ensuring our lineage persists even if Earth becomes uninhabitable. Or we could end within centuries, a brief, bright flash of intelligence that burned out quickly. Dinosaurs didn't choose their fate. We're choosing ours right now. Every decision about climate, resources, technology, warfare shapes our timeline. We're writing our own ending, whether we acknowledge it or not. The question is, what story we want to tell. Do we end like dinosaurs, victims of circumstance beyond our control? Or do we end through choices we made, warnings we ignored, consequences we saw coming? The first is tragedy. The second is farce. Right now, we're trending toward farce. We know what's happening. We know the solutions. We're choosing inaction anyway. Future species will study this moment with confusion. How could beings smart enough to understand their extinction not prevent it? The answer, they'll conclude, is that intelligence doesn't guarantee wisdom. Knowledge doesn't ensure action. Understanding threats and eliminating them are different skills. We evolved the first. We're still developing the second. Maybe we develop it in time, maybe we don't. Either way, Earth continues. Life persists. Evolution grinds forward. The universe doesn't care about humanity specifically. It cares about existence generally. We're one expression of matter, organizing itself into complexity. When we end, matter will find other expressions, perhaps better ones, perhaps worse. Qualitative judgments don't apply at cosmic scales. There's only change, endless and indifferent. The story of dinosaurs began 230 million years ago with small reptiles in a devastated world. It ended 66 million years ago with an asteroid and a planet on fire. Our story began 300,000 years ago with upright apes in Africa. How it ends remains unwritten. We're living in the middle chapters, the part where tension builds and outcomes remain uncertain. The ending could be triumph or tragedy, or something between. But it will be an ending. That's guaranteed. Time ensures it. What we do until then determines whether we're remembered as wise or foolish, whether our extinction was preventable or inevitable, whether we left Earth better or worse than we found it. Dinosaurs had no such choices. They lived according to instinct and evolution, shaping ecosystems without intention, dying without comprehension. We're different. We know what we're doing. We understand consequences. That makes us accountable in ways dinosaurs never were. So here's the final lesson. Existence is temporary. Dominance is circumstantial. Survival is luck combined with adaptation. Nothing lasts forever. Everything ends. But between beginning and end, there's life. Complex, beautiful, improbable life. Dinosaurs had their time. We have ours. What comes next will have theirs. The chain continues until the sun dies and Earth becomes uninhabitable. Then it ends completely. Until then, the story goes on. Different characters, Same themes: time, change, persistence, extinction, survival, repeat. We're not the climax of evolution. We're one chapter in an unfinished book. When our chapter ends, the book continues. That's not depressing. It's liberating. We're not carrying the weight of cosmic significance. We're just here now, trying to survive like everything else. When we succeed, we celebrate. When we fail, we learn. When we go extinct, something else begins. That's the pattern. That's always been the pattern. Dinosaurs understood this instinctively. We understand it intellectually. Now we need to understand it practically. Act like survival matters while accepting that extinction is inevitable. Fight entropy while respecting its victory. Persist while acknowledging impermanence. That's the challenge. That's the test. Whether we pass or fail, the universe moves on. Time doesn't wait. Neither should we.